In lesson 8B, we're going to build a confidence interval for a proportion. What we're going to do is we have to copy the data at the bottom of this problem to Excel. So let's go down there. We have employee status, ethnicity, Hispanic, not Hispanic. The status is promoted or not promoted. These numbers here in the first column, they're just stand-ins for the employee name so we can maintain confidentiality. So that first column is not really a variable. When you copy the data, make sure you copy the entire data set plus something outside of the table. So I copied all this data plus the S in submit question. I'm going to right click, copy. I'm going to paste it in cell A1. Right clicked in A1, I chose match destination formatting. So I don't have any of the HTML junk that comes in from the website. Now, if you go to the instructions at the very top, we need to compute the frequencies for the following table. So we need to build a pivot table where we have a column of not promoted and a column for promoted, and then rows for Hispanic and not Hispanic. This is a pivot table. So we're going to go to Insert on Excel. We're going to click Tables, Pivot Table. Now, I've already highlighted the data, right? We want to highlight just the data in the table, not the columns. So I'm going to click on the bottom row here. And we go to the very top. I'm going to include the names of the columns. So I have A1 to C105. So A1 is the first cell on the left, and the final cell on the right is C105. And you can see the Vega sign is around the data. Right? So then I'm going to click on existing worksheet for the pivot table. I'm going to put the pivot table in cell E1 of the existing present Excel worksheet. I'm going to click OK. I'm going to drag this across here so you can see it better. Now I need to build a pivot table. Now notice I have to put ethnicity on the rows. So I'm going to drag ethnicity here to the rows. I'm going to drag status to the columns. Now if I drag employee ID to values, it's going to sum. See, that's going to sum those values. These values, these numbers are really not numbers. They're synonyms for person's name, people's name. So summing them has no meaning. Now, I can change this to count by clicking the down arrow here and then clicking value field settings and change it to count. There's my counts. Those are my frequencies. Another way to do it is to just drag ethnicity, because ethnicity is a categorical variable or a qualitative variable. I can just drag ethnicity down here and it will automatically count. That's the default. Or I could have dragged in status. And status, like ethnicity, is a qualitative or categorical variable. In that case, the default for Excel is to count things. This 37 is the number of people in the sample who are not promoted and Hispanic. This 21 is the number of people who are promoted and Hispanic. This is the number of people who are not promoted and not Hispanic. And this is the number of people who are promoted and not Hispanic. With this pivot table, I can easily fill in my information. The number of Hispanic and not promoted is 37. The number of Hispanic and promoted is 21. The number of people who are Hispanic is 58. It's just the sum of the two, right? The number of people who are not promoted and not Hispanic is 34. The number of people who are promoted and not Hispanic is 12. And the total not Hispanic is 46. The total number of people not promoted is 71. The total number of promoted is 33. And the total number in the sample is 104. I'm going to press enter to make sure I got the answers correct. The number of promoted non-Hispanics, 12. And the number of non-Hispanics is 46. The proportion of promoted non-Hispanics is the ratio of 12 and 46. What I'm going to do is I'm going to come up here and I'm going to type equal, put my Vegas sign around 12. I'm going to press divide, and then I'm going to use my arrow key and then put my Vegas sign around 46. I'm going to press enter. I need 3 decimal place accuracy. I'm going to come up here and change this to 3 decimal places. So I have 0.261. I'm going to paste that right here, and then I'm going to press enter to make sure I did it right. So this is the proportion, PN. Now I need to do the standard error of the proportion. The way you do this is you type equal, and you come up here to the 0.261. You multiply that by its complement. probability. 1 minus that portion. So this is P times 1 minus P. 1 minus P is the complement of P. That number right there, a variance of ones and zeros, where one, it's equal to 1 if the person is not Hispanic and promoted, 0 otherwise. And you can, this right here is the variance of ones and zeros. I'm going to come over here and I'm going to show you what's going on. So the first thing I'm going to do is I'm going to sort column B, and I'm going to sort, I'm going to do a double sort. And I'm looking at non-Hispanics, right? So I need to come down here to non-Hispanics. I'm going to type 0. I'm going to copy this all the way down. These are all going to be zeros, not promoted, not Hispanic. And then I'm going to come down here. I'm going to make all these ones. Okay, so I got a bunch of ones and zeros. 1 if not Hispanic, promoted. 0 if not Hispanic, not promoted. So now if I come up here and I type equal var.p, and I highlight these ones and zeros, I'm going to get the same number that you see above. Okay, they're the same number. So P times 1 minus P equals the variance of the numerical variable I created, which is the dummy variable, that is 0 for non-Hispanics who were not promoted, and 1s for non-Hispanics who were promoted. This is the variance of the ones and zeros. Imagine doing this experiment like 1,000 times. And each time you do it, you get a different portion. Maybe one time you get 0.261, the next time you get 0.25, the next time you get 0.24, the next time you get 0.27, et cetera, et cetera. So if you replicate this experiment 1,000 times, you're going to get 1,000 different one of those, right? You're going to get 1,000 different values for this proportion. This is the variance of the ones and zeros for this specific sample. I want an estimate of the variance of 1,000 of these proportions, where each of these proportions is different from sample to sample. I want an estimate of the variance of sample proportions. The way to get that is I divide this by the sample size. And the sample size is 46. Now, this is the estimated variance of the thousands of sample proportions I get from replicating this experiment 1,000 times. This is what we estimate it to be. Once I take the square root of it, now I have the standard error of this proportion. And it's 0.064743. And I only need 3 decimal places, so I'm going to copy it. I'm going to paste it right here. To answer this question, we need to grab this 90% confidence up here. Now, your confidence level might be 95%. It might be 99%. Mine is 90%. I'm going to click on a new tab. I'm going to type stat, S-T-A-T, spell the word distribution, and then add an S. So statdistributions.com. And that's all you need. And then press enter. Statdistributions.com. And the default is a normal distribution. I want to change this to not 2 tails, but 2-sided mean to z. I'm going to change the p-value to 90%. So the area in the hump, not including the tails, this purple area is called 1 minus alpha. So right here, I'm going to type 1 minus alpha. And my 1 minus alpha is 90%. So in a normal distribution, this is what it looks like. I got this upper tail that's white. I got this lower tail that's white. And the probability of being between this number on the number line and this number on the number line, the probability of that happening is 0.90. And we call this area confidence. We call the white area here and here significance. So this white area is significance. The inside area is the confidence. So my alpha level is equal to 1 minus the area in the middle. And remember, under a distribution, that area has to add up to 1. So my significance level is 10% when my confidence level is 90%. And then I want to split the alpha in 2. I have half the alpha here, and I have half the alpha here. So now I want to split the alpha in 2 parts. I want to split it in 2. So now I just come up here and I divide this by 2. And I get 5%. Let's go back to the lesson. So my alpha divided by 2 is 0.05. Or I could type 5%. Now I need to find the critical value. Now it says the critical value is 1.645. The normal distribution is symmetric. So this value here is a negative 1.645, and this is a positive 1.645. Now in Excel, I'm going to type critical value here. In Excel, I could type equal norm. This is just the normal distribution. You can have you can pick infinite many values for the mean and infinite many values for the standard deviation. When I type norm.s, I get the standard normal distribution, and its mean is 0, and its standard deviation is 1. Now, if I type dist, I want to feed it a number on the number line. I don't know the number on the number line yet. So what I want to do is I want to feed it an area under the curve. So I want to type norm.s.inverse. Now, this can be a problem because it's going to come out negative. I want to make it positive. So I can make it positive two ways. I can type absolute value ABS, and that'll make it positive. Or I can just put a negative sign in front of it because two negatives become positive. Or I can just know that I got to type in a positive 1.645. And notice it agrees with this right here. That's my critical value. I'm going to press enter. And I give you the formula right here, right? Norm.s.inverse. The margin of error is just the standard error times the critical value. And we get to 3 decimal places, we get 0.106. Lower limit and the upper limit. The lower limit is the sample proportion minus the margin of error. The upper limit is the sample proportion plus the margin of error. We copy and paste those in, and then we can press enter, check our work. So the way you interpret this is we are 90% confident that the proportion of promoted non-Hispanics is between 0.154 and 0.367. We can't know what the true proportion is. All we can do is take a random sample and then estimate where the true proportion lives. At worst, it's 15.4%. At best, it's 36.7%. That's all we can do in the real world. We can't know the true population proportion. Now we want to calculate a 90% confidence interval for the portion of promoted Hispanics. And these are non-Hispanic. And these over here are Hispanic. The number of promoted Hispanics is 21. The number of Hispanics is 58. Portion of promoted Hispanics is 21 divided by 58. Okay, so the standard error, if you remember, is this portion times 1 minus that proportion divided by the number of Hispanics, which is 58. And we take the square root of that ratio, and we get 0.063. So it's pretty close to that value, right? These are pretty close values. And then all this information is just copied, right? All this information is just copied all the way down. Now, for the margin of error, we have to multiply the critical value times the new standard error. And for the lower limit, we take the estimate of the proportion of Hispanics who are promoted, and we subtract off that margin of error. And then for the upper limit of the confidence interval, we take the estimate of the proportion of Hispanics who are promoted, we add to it the margin of error. So that's our new margin of error, our lower limit for this particular problem, and our upper limit for this particular problem. I'm going to press enter to make sure we got it correct. Now we want to calculate a confidence interval for the difference in the proportion of promoted Hispanics and the proportion of promoted non-Hispanics. So the difference, PN minus PH, is negative 1.01. That's the point estimate of the difference. Now it's negative. Why is it negative? Because the proportion of Hispanics who are promoted is greater than the proportion of non-Hispanics who are promoted. So it'd be a negative means Hispanics have a higher promotion rate. Now I'm going to calculate the standard error of the difference. Now, this is the formula we're going to use.
This is the variance of the promotion proportions for Hispanics that would result from repeating this experiment thousands of times. This is the variance of the promotion proportions for non-Hispanics that would result from repeating this experiment thousands of times.
We're going to sum that and then take the square root.
First,
I'm going to get rid of this information. Now, normally this is not a good idea. Normally I click on the number, but this is a pivot table. And when you're using a pivot table like this, it can be very confusing. Instead of clicking on it, I'm going to type 46. I'm going to do the same thing over here. I'm going to get rid of this get pivot table data thing. I'm going to divide it by 58. Now that doesn't change the value of anything. Our standard error is still 0.063, and this standard error is still 0.065. Now what I'm going to do is I'm going to take everything in here. I'm going to copy that. I'm going to paste it right here. And then I'm going to press enter. And then what I'm going to do is I'm going to come over here. I'm going to grab everything inside of the parentheses. I'm not going to grab the square root. I'm going to grab the stuff inside the parentheses. I'm going to copy that, press enter. I'm going to come over here, and then inside the parentheses, I'm going to add an add symbol, and I'm going to paste what I just copied. This is P times 1 minus P divided by its sample size. And this is P, the other P, times the other 1 minus P divided by its sample size.
this is the variance of the promotion proportions for Hispanics that would result from repeating this experiment thousands of times. This is the variance of the promotion proportions for non-Hispanics that would result from repeating this experiment thousands of times.
When I add the two together,
this represents the variance in the differences between promotion proportions for non-Hispanic and Hispanics based on repeating this experiment multiple times.
And then I take the square root of that, and I press enter. I'm still using a 90% confidence interval. My critical value is still 1.645. My margin of error is the critical value times the standard error. I need to pull this out. I put difference above here. And then I got the upper limit and the lower limit. So the lower limit is just the point estimate of the difference minus the margin of error. The upper limit is the point estimate of the difference in proportions plus the margin of error. Now I can use this information to fill in the rest of my table. Okay, so I had the point estimate of the difference. This is the difference in proportions. The standard error of the difference. The significance level divided by 2 is still 0.10 in my case. The critical value is still 1.645. The margin of error in my case is 0.149. The lower limit is a negative 0.250. The upper limit is 0.048. I'm going to press enter to make sure that my answers are correct. The alpha divided by 2 is 0.05. Because 0 is inside the confidence interval. The confidence interval implies that we are, in my case, 90%. The confidence interval implies that we can be 90% confident that being promoted and ethnicity are independent events. When 0 is inside this confidence interval, what we're saying is the difference here is probably equal to 0 when it's 0 is inside the confidence interval. If both these numbers are positive, what we're saying is this difference is probably positive or 90% confidence positive. If both these numbers are negative, we're saying this difference, we're 90% confidence this difference is negative. But the confidence interval of this difference has a negative lower limit and a positive lower limit, and 0's in between negative and positive. We're concluding that this difference is probably 0. So what we can say is because 0 is inside the confidence interval implies that we can be 90% confident that being promoted and ethnicity are independent events.